dream that someday I would just fly, fly away. And I always knew I couldn't stay. So I had a dream that I'd just fly away. I've been on my own for a minute. Is it only me out there? Searching for the place to begin it. Is it me? Is it you? Is it fear? Standing on the line I was given. People stare and ask me why I'm here. No one seems to think that I fit in. But I don't wanna be like them. No, 'cause I don't wanna be like them. 'Cause I know that I had a dream that someday I would just fly, fly away. And I always knew I couldn't stay. So I had a dream that I'd just fly away, away. Oh, 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 I fly away. No one knew how low I was feeling. I was scared to reach for it all, knowing I was here for a reason. But I was scared that if I tried, I'd fall. So where do I go now that I'm in it? I never thought it'd be like this. Dreamed it all my life and I did it. Thought the grass was greener than it is. 'Cause I had a dream that someday I would just fly, fly away. And I always knew I couldn't stay. So I had a dream that I'd just fly away, away. Oh, 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 I fly away. Oh, 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 I fly away. 'Cause I had a dream that someday I would just fly, fly away. And I always knew I couldn't stay. So I had a dream that I'd just fly away, away. Oh, 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 I fly away.
Let's talk about love. Is it anything and everything you offer? Or do the feeling hurt you? I know the feeling hurt you.
'Cause maybe the night that my tears might let me know. All the stars are close, all the stars are close, all the stars are close. 'Cause maybe the night that my tears might let me know. All the stars are closer, all the stars are closer, all the stars are closer.
Tell me what you gon' do to me. Confrontation ain't nothing new to me. You could bring a bullet, bring a sword, bring a morgue, but you can't bring the truth to me. You ain't all your expectations. I don't even want your congratulations. I recognize your false confidence and calculated promises all in your conversation. I hate people that feel entitled. Look at me crazy 'cause I ain't invite you. Oh, you important, you the moral to the story. You endorsing, motherfucker, I don't even like you. Corrupt a man's heart with a gift. That's how you find out who you're dealing with. A small percentage you I'm building with. I want the credit if I'm losing or I'm winning. On my mama, that's the realest shit.
Let's talk about love. Is it anything and everything you offer? Or do the feeling hurt you? I know the feeling hurt you.
'Cause maybe the night that my tears might let me know. All the stars for me. If you do, I won't move. I ain't just cry for no reason. I ain't just pray for no reason. I give thanks for the day, for the hours, and another way, another life breathing. I did it all cause I feel good. I wouldn't do it all if you feel bad. Better live your life. We're running out of time. Let's talk about love. Anything you ain't wanted. Cause maybe the night that my tears might let me know all the stars are closer, all the stars are closer, all the stars are closer. Maybe the night that my tears might let me know all the stars are closer, all the stars are closer, all the stars are closer.
All my life been hustling and tonight is my appraisal. Cause I'm a hooker selling songs and my pimp's a record label. This world is full of demon stocks and bonds and Bible traders. So I do the deed, get up and leave a climber and a sadist, yeah. Are you ready for the sequel? Ain't ready for the latest? In the garden of evil, I'm gonna be the greatest. In a golden cathedral, I'll be praying for the faithless, and if you lose, boo-hoo. Hey, look, ma, I made it. Hey, look, ma, I made it. Everything's coming up aces, aces. If it's a dream, don't wake me, don't wake me. I said, hey, look, ma, I made it. Friends are happy for me, or they're honeysuckle phonies. Then they celebrate my medals, or they wanna take my trophies. Some are loyal soldiers, while these other thorns are rosy. And if you never know who you can trust, then trust me, you'll be lonely. Oh, are you ready for the sequel? Ain't ready for the latest? In the garden of evil, I'm gonna be the greatest. In a golden cathedral, I'll be praying for the faithless, and if you lose, boo-hoo. Hey, look, ma, I made it. Hey, look, ma, I made it. Everything's coming up aces, aces. If it's a dream, don't wake me, don't wake me. I said, hey, look, ma, I made it, I made it. I said, hey, look, ma, I made it, I made it. I see it, I want it, I take it, take it. If it's a dream, don't wake me, don't wake me. I said, hey, look, ma, I made it. Mama, best believe it. Mama, best believe it. Think I must be dreaming, but awake and breathing. Mama, best believe it. Mama, best believe it. Think I must be dreaming. Hey, look, ma, I made it.
Good evening. I invite everyone to please rise for our graduation processional. Caleb.
Please be seated. Bonsoir, Mesdames, Messieurs. Guten Abend, meine Damen und Herren. And as we say in Switzerland, grüezi miteinander. Welcome and good evening. On behalf of the faculty and staff of the Smead Department of Aerospace and Engineering Sciences, I welcome you to this recognition and graduation ceremony for the Spring 2024 graduates. I'm Department Chair Hans-Peter Schaub. It is my pleasure to introduce our platform party. To my right, we have the Dean of College of Engineering and Applied Science, Keith Molinar. Next, right behind me, is Smead Aerospace Department champion and newly minted honorary degree recipient from the Regents of the University and Smead. To her left, tonight's keynote speaker and alumni, Laura Stiles. Next, Associate Chair of the Undergraduate Curriculum, John Evans. And Associate Chair of the Graduate Program, Bob Marshall. It is an honor to represent this world-class department and the amazing students that have chosen to study here. It is a pleasure to welcome all the family members and friends of these students who are receiving their degrees today. These family members have traveled across the state, the nation, and some even across the globe to celebrate with the graduating students this major milestone in their career. In summer 2019, the department had the pleasure of moving into a brand new building constructed specifically to support our aerospace engineering sciences research needs. Going off script briefly, I just want to say this building would not exist with the support and care and passion of Anne Smead and her husband, Michael Byron. I want to give a shout out. Thank you both for all this support. So with this growth, we have now grown up to 1,200 undergraduates and 550-ish, some keep graduating, graduate students in our department. The department continues, as a result of this growth, to revise and improve experiential undergraduate curriculum, and we look forward to beginning rolling out this new curriculum with the freshmen starting this fall. Emerging from the pandemic years did bring some challenges that have actually continued, but some things are good. For example, all our graduate courses now remain available online in an online format, allowing over 100 graduate students to work full-time jobs all over the nation and the globe while pursuing a graduate degree. Some change is good. The department's research remains strong and is exploring everything from, this is a major list, but shortly, atomic scale material properties, supporting human life in space, developing some of the most complex structure, fluid simulation in complex environments, to exploring environments with uncrewed autonomous aerial vehicles. A quick shout out, if you watch the new Twisters movie coming out later this year, you will see some UAVs that have come from here. And finally, to exploring the near-Earth space environments, the lunar region, asteroids, Mars, and even other planetary bodies. It is an amazing time to be graduating with an aerospace degree. The industry demand from our graduates never let up during the economic downturns. In fact, it has only grown. Our undergraduate and graduate enrollments have doubled over the last 8 years, and we have already pretty much filled up this new aerospace building. We have become one of the largest aerospace programs, both nationally and internationally. The graduate seating here before you have also witnessed the move to the new building, endured the COVID pandemic, as well as record wildfires. They learned to face adversity and to face it with determination and drive. Students are now finding jobs not only in the classical aerospace industry and government research labs, but are also entering exciting emerging new businesses starting up around orbital servicing, developing autonomous drones, but also supporting humans, tourists in space. I look forward to learning from these graduates in 5 to 10 years and hearing about this exciting work they're about to engage in. To our graduates, in these rapidly changing times, there is at least one thing you can be certain of. Your Smead Aerospace family is incredibly proud of you today. Today, we have overcome challenges that neither you nor any of our faculty and staff have ever experienced. And despite all that Mother Nature, and quite frankly, some of the professors, have thrown at you, you're about to be recognized to receive the Doctor of Philosophy in Aerospace Engineering, the Master of Science in Aerospace Engineering Sciences, and the Bachelor of Science in Aerospace Engineering Sciences. And here we are, the faculty and staff of the Smead Department of Aerospace Engineering Sciences at the University of Colorado, standing with you, as we always will, and prepared to call out your name and to individually recognize you as a recipient of the Smead Aerospace Engineering Sciences degree, and to welcome you as the newest Aero Buffs. To get this started, please allow me now to introduce the Smead Aerospace Associate Chair for the Graduate Program, Professor Bob Marshall. Professor Marshall, there's Bob. Professor Marshall will present a brief history of our academic regalia, the hooding ceremony of the recipients of the degree of Doctor of Philosophy, and read out their names and dissertation titles.
It is my pleasure to present to you a group of students who are dressed a little differently than the rest, our PhD candidates. These students are not only dressed differently, but their degree, paths, and accomplishments are unique. After receiving a bachelor's degree, they somehow decided that was not enough. They've spent at least 3, and some up to 8 more years in school, beyond their bachelor's and master's degree. While they have completed additional coursework during their time in our PhD program, their primary focus has been on performing original research to create new knowledge and technologies to improve society. While completing their degrees, the PhD candidates successfully passed a preliminary exam and a comprehensive exam, and finally defended their thesis research in front of a committee of faculty members. They've also documented their research in a written dissertation that is frequently the length of a novel. Indeed, most of the material in the vast array of textbooks that we use in our undergraduate courses was initiated by somebody's doctoral research. Most importantly, our PhD students in engineering are working on technologically challenging problems that impact our society. For example, some students are discovering novel methods to explore other planets, moons, and asteroids. Others are investigating how to support life in space, how to design and build materials and structures which save energy, or how to use aerospace systems to remotely sense either the Earth or space environment. The use of clusters of unmanned systems is changing how we explore our world. Their work is truly changing our world and improving our quality of life. Today we will recognize our PhD candidates in a traditional ceremony called the hooding. The hood, given to each candidate by their faculty advisor, symbolizes the awarding of the doctorate. The hooding ceremony originated in European universities in the 11th or 12th century and was introduced to distinguished graduating students as they began their academic careers. Hooded robes were used by scholars for warmth as they worked in unheated medieval libraries. Over time, the hooded robes became largely symbolic and ceremonial. Today, the hood signifies the transition from PhD candidate to colleague. The hood has some unique characteristics. The wide velvet trim represents the PhD degree, and the colors represent the institution awarding the degree. You will notice a variety of regalia among our faculty, representing the different institutions where we completed our PhDs. This evening, we are proud to present each of our doctoral graduates with a hood adorned with the University of Colorado colors of silver and gold. Family and guests, please remain seated during the recognition of all students. Candidates, as you cross the stage, head back to your seat. We will now present the candidates for the Doctor of Philosophy degree. John Marino, on the development of a multistatic meteor radar network for investigating dynamics of the upper atmosphere, meteor science, and space weather. Brody Wallace, a lunar surface pseudolite architecture for regional communication and radio navigation. Alex Hurst, learning enhanced nonlinear model predictive guidance for fixed wing small uncrewed aircraft. Alex is also a Smead Scholar. John Skovbeck, interval Markov abstractions of data-driven stochastic systems for strategy verification and synthesis. Justin Michael Cottinger, enabling next-generation multi-robot task and motion planning with conflict-based search. Carolina Tatiana Chisholm, development and characterization of a miniature vectorized rubidium magnetometer for spaceborne measurements of Earth's magnetic field. Riley Reed, novel high angular resolution imaging techniques for energetic electron pitch angle observations. Christopher Flood, time transfer architectures for small satellite platforms. Kristen Lee Bruchko, trajectory design using sampling-based kinodynamic planning in multi-body systems. David Lujan, methods to explore families of quasi-periodic orbits with applications in astrodynamics. Jesse Greaves, autonomous navigation for distributed space systems via spacecraft-to-spacecraft absolute tracking. Yashika Khatri, semi-analytical uncertainty propagation and conjunction assessment. Dominic Henry, spacecraft trajectory design and control leveraging quasi-periodic orbits. Dominic is also a Smead Scholar. Alex James Meyer, the dynamical evolution of perturbed near-Earth binary asteroids. Tara Lyson-Deca, astrodynamics-informed kinodynamic motion planning for relative spacecraft motion. Tara is advised by Professor Jay McMahon, who could not be here today. Anabit Pedros Farah, leveraging natural dynamical structures for gravity field characterization of small bodies, also advised by Jay McMahon. Jacopo Villa, robust onboard vision-based navigation and characterization at small celestial bodies, also advised by Jay McMahon. Dahlia Baker, the influence of asteroid surface features on the Yorp effect and dynamical evolution, also advised by Jay McMahon. Excused. Adam Herman, reinforcement learning for spacecraft planning and scheduling. Samuel Weston Albert, aerocapture entry and co-delivery in uncertain planetary atmospheres. Evan Tucker, improving low-degree gravity estimates through new laser ranging satellites, ground stations, and combination solutions. Edward Highcope, improving the estimates of regional impacts of sea level change with high-resolution digital surface models. Patrick Pichulti, strategies for enabling self-sufficient anomaly response in deep space habitats. Sophia Ann Zacharine, characterizing self-sufficiency and habitability for autonomous deep space habitat operations. Eric Brighton, a systems engineering approach to holistically evaluating cockpit design and performance. Sam Eshema, sensor suite optimization process for environmental control and life support systems that utilize machine learning for anomaly detection and diagnostics. It's your fault. Mitchell Glenn Woollever, ionic liquid property prediction via quantitative structure property relationships with application to electrochemical Bosch carbon formation catalyst renewal. Jacob Ryan Kintz, an adaptive autonomous system informed by unobtrusive measures of trust, mental workload, and situation awareness for deep space exploration. Aaron Allred, galvanic vestibular stimulation as a countermeasure to motion sickness in astronauts. Victoria Kravitz, a computational tool to model astronaut neurovestibular adaptation to altered gravity. Aviral Prakash, scale-resolving simulations and data-driven subgrid modeling for complex turbulent boundary layer flows. Basu Parmar, data-driven turbulence modeling. Kevin Julian Bonnet, new passive and active techniques for entry, descent, and landing trajectory and atmosphere reconstruction.
It is now my pleasure to, sorry, they moved on to the next. There we go. I would like to present to you the candidates for the degree of Master of Science in Aerospace Engineering Sciences. Today we celebrate the remarkable accomplishment of these students who have dedicated years of study, research, hard work to reach this significant milestone in their journey. Throughout this journey, these students have overcome numerous obstacles and challenges, showcasing their resilience and determination. From working through tough technical challenges in the lab to late-night study sessions after a full day of work, each candidate has shown a relentless pursuit of excellence in aerospace engineering sciences. Their accomplishments are a testament to the hard work, passion for innovation, and commitment to advancing the boundaries of aerospace technology.
Ashwin Raju. Benjamin Chupik. Cameron Kratt. Neil Bruin. Zahariah Oginski. Nir Patel. Aaron Holt. Luke Tafer. Tyler Wesley Mason. Son Pham. Ian Graber. Sarah Heath. Eric Richard Turner. Christopher McMaster Bisbee. Kintan Sophia Sergani. Jasmine Jaya Chada. Victoria Hurd. Sarah Leary. Samuel Allen Curtin. Raj Kadia. Khalid Al-Nakbi. Matthew Chi. Parvati Parameshvar Suresh. Suman Chaudhry. Adam Ryan Harris. Samuel Goodwin. Cham Childress Potter III. Abdoulaye Mamadou Diallo. Guido Kavirin Insinger. Skylar Edwards. Adrian Pickerel. Tycho Laurson Cinquini. Alicia Wu. Akanksha Rajshekar Nelakanti. Matthew Grew. Addison Kaylee Woodard. Varnita Prakash. Kellen Andrew. Teresa Pena Mercade. Manuel Enrique Puyana. Alexandra Bain. Alex William Nelson. Julian Lima Bouillard. Joaquin Ramirez. Andrea Lopez. Reese Liu. Sumit Shriram Saman. Sam Packard. Luca Trapani. Jade Babcock Chi. Benin Gaddis. Michael John Miller. Alexander Fitzgerald. Blake Robert Wilson. William Alexander Gravel. Nathan Kongchen Zhao. Cody Watson. Benjamin Four. James Perkins.
This is where I get my points in with exercise. Next, it is now my pleasure to introduce Anne Smead, a longtime champion of our department and impact to the aerospace industry. Her community and this campus has been immeasurable. And I want to share a few of the outstanding achievements from Anne's career. She was the first female systems engineer at IBM. She was a commercial real estate executive which included managing the real estate and environmental group at Kaiser Aerospace. She taught financial analysis at real estate for organizations throughout the United States and in Eastern Europe shortly after the wall fell. She's a board member of numerous community organizations in the Vail Valley, to include the Vail Valley Foundation, where she's also the chair, the Vail Health, the Shaw Cancer Center, the Stedman Fillion Research Institute, Vail Mountain School, where she's also the chair, and Walking Mountain Science Center. She was elected the Vail Valley's Citizen of the Year in 2013. And she has established numerous endowed funds at CU and other institutions. And yes, Anne is the SMED in SMED Aerospace Engineering Sciences, the SMED program. A major part of the SMED program that Anne helped us set up are the SMED Fellows. You just saw two SMED scholars, Dominic Henry, Alex Hurst, right down there. Congrats again to you both. But just going off script for a second, I've been to many universities where you can see named this, named that, and people have generalists, they donated all kinds of resources to get buildings with their names on it and stuff. Anne Smead and her husband Michael Byron are not just providing support. More importantly, they're providing time and their heart and passion for our education program. This program would not be what it is today without the dedicated support. I know for myself, I wouldn't be here if it wasn't for their support. So please give me a big hand for helping me welcome Anne Smead to the podium.
Excuse me while I get organized here. Thank you so much. You have achieved so much in your short time on this earth, and I am so very proud of each and every one of you. Congratulate yourselves, will you? You don't take time to do that, right? Congratulate yourselves. You're so busy with your research, your studies, your jobs, hopefully a little social life, that sometimes I think we just don't stop a minute to say, hey, look in the mirror, I have accomplished something, and I want each and every one of you to do that, at least every week, and don't ever forget it. The most important thing I can say tonight is I want to thank you. You, not Michael and I, but you, the faculty, the staff, the leadership of this department, of this college, and this university have made SMED Aerospace what it is today. And I want to thank each and every one of you for that. It is truly my honor to be here, not your honor to be with me. I have a wonderful opportunity tonight to introduce you to one of the most outstanding females I've met in a long time. I started reading her bio, I started looking at her speeches, and I thought, what has this woman not done? She graduated from the University of Kansas in 2008, and I was amazed to hear that she was the only female in her engineering class graduating that year. Yeah. Look around tonight. I honestly didn't believe it. In 1964, I was the first systems engineer with IBM, as HP said. But that was 2008, and she was the first female, or she was the only graduating female in that class. She came to CU, and in 2010, she received her master's, 2013, her PhD, and along with her PhD, she earned her skydiving instructor rating. Told you this is an amazing woman. She's currently a systems engineer at Blue Origin in Seattle, Washington, where she works on mechanical systems, integrated vehicle test, and launch operations. She has a motto, and this might be worth keeping. Her motto is, work hard, play hard. When Robert Meyerson, the president of Blue Origin, learned about her skydiving and her parachute interest, he selected her as the responsible engineer for the crew capsule parachute system. On a personal note, just this last November, Laura was part of a 65-woman parachute team, jumping out of 4 airplanes to set the world record for the largest vertical formation in a head-to-earth flying position. That's amazing. And now, certainly Laura has combined her work and her passion together to create a successful career. Please welcome CU alum, Laura Stiles.
On February 21st, 1967, Ed White, Roger Chaffee, and Gus Grissom were the victims of a tragedy, a fire in the Apollo 1 command module at the launch pad at Kennedy Space Center. It was a dark day that shook the space program to its core. Thank you. The aftermath left engineers, flight controllers, and everyone surrounding the terrible event distraught. They reflected somberly on the accident, self-searching, desperately wondering where they went wrong, both in the program and on a personal level. Today, as we celebrate your achievements as a remarkable group of graduates, you may wonder why I choose to begin with a tale of tragedy. It is because I believe the true power in this story lies in what came next. How from a tragedy emerged a leader whose words would define a better and stronger program and shape a team that was to complete one of the biggest engineering accomplishments of the century, landing humans on the moon. In the wake of that fateful day, that leader who stepped up was Flight Director Gene Kranz. Gene called a meeting with everyone on the team, and he started with a powerful message of accountability. He said, somehow, somewhere, we screwed up. It could have been in design, or build, or test. Whatever it was, we should have caught it. Not one of us stood up and said, damn it, stop. He next laid the foundation for what was to come. He told them, from this day forward, flight control will be known by 2 words, tough and competent. Tough means we are forever accountable for what we do or what we fail to do. We will never again compromise our responsibilities. Every time we walk into mission control, we will know what we stand for. Competent means we will never take for granted. We will never be found short in our knowledge or our skills. Mission control will be perfect. To drive home the point, he directed everyone on the team, when you leave this room, you will go to your office, and the first thing that you will do is write tough and competent on your blackboards. It will never be erased. These words, each day when you enter the room, will remind you of the price paid by Grissom, White, and Chaffee. Back in 2001, I was leading a mission control team that was working fiercely toward the launch of our New Shepard suborbital vehicle, where we would first put humans on top of our own spacecraft. I came across these words as I read Gene Kranz's book. It resonated incredibly deeply with me. The message of tough and competent had not aged one bit. And these words, his message, it's not just about mission control, it's about every aspect of what we as aerospace engineers do. It's about what every one of you as proud graduates of the University of Colorado at Boulder Department of Aerospace Engineering going out into this incredible field must now internalize. You have just passed through a door, and one that was not trivial to get through, and you have an exciting world of opportunities in front of you. Opportunities where you also must be tough and competent. You must know what you stand for and acknowledge the impacts of the work that you will soon be doing. Tough to me means two things: being tough on yourself and being tough on others. Most fundamentally, it means accountability. Your professors here were not hard on you because they wanted you to suffer. Probably, maybe. No, they were tough on you to prepare you for taking responsibility for doing things right in all the work that you do, to challenge you to do your best and always act with integrity. Everyone can likely think of a time where they didn't do something right. Personally, I will always remember the first time I made a mistake in which someone could have gotten hurt. We were testing the hydraulic system for a propulsion module for our newly assembled rocket. I was the console operator for the test, sending commands to the rocket, monitoring the data. And before he approached the vehicle, one of the engineers called over, "Is pressure transducer 123 below 50 psi?" Something like that. I looked quickly at the console to get him a fast answer and said, "Yes." But he already had a suspicion that something wasn't right with the test, so he came over to the console and looked at the data himself. His finger slowly pointed to the pressure reading that was, in fact, not below a safe pressure. So here I was, in the first year of my career, with this brilliant engineer now staring into my soul, about to be tough on me. He said, "It's really important to read the right number." Yep, sounds pretty simple. I grimaced, I was so embarrassed, but I knew I was responsible. And you'd better believe I thought long and hard about how I would not make that mistake again. So it was my turn to be tough on myself. I needed to do better. And my perspective transformed as I realized how important every individual's role and each individual action is in achieving mission success. Whether during a test or way back in the design phase, the build phase, or maybe at the last moment, going around mission control where each controller commits their resounding go before launch, every step is a chance to make sure that things are done right, or as Jean said, to say, "Damn it, stop." Most of our mistakes will be small or have low consequences. Being tough is being built up by learning from these mistakes. You are going to make them. There are going to be times when you fail, and it will be hard. And if you're anything like me, you might need a little cry to go shake it off. It's fine. What I want you to promise yourself is that when you walk out of here, is that when you hit these inevitable challenges, that you will choose to be tough. They will not stop you. Rather, that is how we as an industry will grow and improve and accomplish incredible things together. Just 2 years after I had made that mistake at the test console, with lessons learned from that and many other experiences, I had the honor of becoming a flight controller for the New Shepard crew capsule. From my seat in mission control, I was entrusted with the responsibility of safe operation and flight of the whole vehicle. Another 3 years after that, I was the senior manager of the launch operations organization, using continuous learning to build a tough and competent team committed to maintaining the highest level of safety and operational excellence. The second piece of what became known as Jean's dictum was competence. And competent doesn't just mean smart. Being the smartest might have made you the best in the classroom, but it is not a ticket to being the best in industry or even in academia. While here at CU, in graduate school, it killed me a bit because the academic world was all I knew. But now I can look back and joke with my former advisor, Hans-Peter Schaub, that I was definitely not the smartest student in his lab. But I was competent at building relationships, at motivating others, and at leading teams of other very smart people. So if you aren't the smartest person in this room, and that's about 999 of you, including me, do the work to know what your biggest strengths are. What are you already competent at? Own it. Use it. What are you not competent at? Make a plan and commit to filling those gaps. I want to stress that one of the most important things about competence is recognizing what knowledge and skills you don't have and being able to say it. Coming out of the SMED Aerospace program, you know so many things, but it is just the beginning, and your entire career will be a learning journey. I didn't know anything about mission control when I got my first opportunity to sit in the seat training as a flight controller. I stumbled through my radio calls, imposter syndrome to the maximum. I also barely knew anything about managing people when I took my first manager role. That's okay. It took constant humility, it took hard work, and it took a drive to learn and make mistakes as I forged my way to becoming competent in those roles. So, graduates, take what you have learned in this exceptional institution, pair it with humility, and add on a never-ending drive to learn and get better, and I have every confidence that you will find true success. The Apollo team in Mission Control back in 1967 not just heard Gene's message, but wholeheartedly embraced it to their core. Barely a year and a half later, in 1968, the first crewed Apollo mission, Apollo 8, successfully sent astronauts around the moon. It inspired all of humankind as we got the opportunity to see our precious and fragile planet from a brand new perspective. Less than a year later, in 1969, we landed humans on the moon. The tale of resilience and recovery following Apollo 1 tragedy is truly legendary. Now, more than 50 years later, we are poised for so many more incredible achievements in the aerospace industry. We're going back to the moon, we're flying helicopters on Mars, we returned a sample of an asteroid back to Earth that some of you worked on. The possibilities are endless. It is a truly thrilling time, and you all are not only going to be a part of it, you are the future leaders. Strive to be tough and aspire to be competent, and you, graduates of the University of Colorado at Boulder, will achieve amazing things. Thank you, and congratulations to the class of 2004. 2004.
Thank you, Laura, for the wonderful speech and words of wisdom. So now it's my absolute pleasure to present to you our final candidates tonight, the candidates for the Bachelor of Science degree in Aerospace Engineering.
Mark Wilborn. Alexandra Sasha Gladkova. Jillian Pace. Becca Blum. Claire Wadman. Ryan Oliva. Santi Huertas. Youngwoo Lee. David Tan. Jace Billman. Max Apollo Fineland. Luke Wesley Arnold. Christian Stanku. John Andrew Davis. Robert Scherer. Lion Foster. Kate Benich. Maitreya Karanjkar. Zach Zur. Ryan Downey. Nicholas Von Unger. Aiden Wood. Ben Verkateren. Evan Winterfelt. Max Fairchild. Joshua Thomas Elston. Matthew Chen. Zach Chen. Alexander Austin Lamb. Emily Schindel. Taylor Meyer. Dylan McKellar Blake. Ashton Nicholas Croft. Michael Sherman. Max Balasubramaniam. Emma Potler. Andrew Poole. Kieran Boyles. Tori D. Morgheim. Angelina Rose Miller. Cheney Sullivan. Ben Wadanapong. Andrew Matthew Pixley. Jennifer Cuevas Morales. Andrew Swackhammer. Andrew Pearson. Tyler Hall. Rithik Gangapathy. Max Deutsch. Suvik Chatterjee. Ben Bowman. Peter Young. Adam Romack. Justin McGregor. Benjamin Drew Helfont. Marcus Van Zee. Javier Zetter Kick. Lucas Chernoff. Yoonhyuk Young. Peach Chaphufang. Yes. Aaron Orshan. Thomas Pierce. Sam Monax. Nate Witonsky. Liam Mazada. Dakota Harris. Blake Evan Wilson. Tan Liu. Ryan Matthew Roberts. Austin Monell. Ethan James Stapp. Brendan Yang Ross. Luis Ernesto Romo. Graham Kersey. Matthew Menendez Aponte. Gerald Sinning Miller. Nick Barbatini. Hideyuki Nakanishi. Sarah Janelle Hansen Nedro. Kristen Grell. Kevin McGough. Jack Iribaran. Sean Vesteca. Sam Honan. J.P. Burbage. Chris Yan. Xiaoyang. Alan Jaffe. Maxine Stoanescu. Moises Pina. Michael Lover Lopez. Zane Vandeveer. Joseph Maki. Ashton Miner. Connor Triplett. Max Perry. Jonathan Morris. Madison Davis. Mackenzie Davis. Anthony Morello. Nico Kwame Madrid. Joseph Hunter. Hector Ruby. Isaac Chavaria Esquivel. Mitchell Buck. Blake Hunnam. Timothy Bearer. Tanner Brummond. Joshua Camp. Coleman Cross. Nicholas Jordan Grant. Joshua Kendrick Goodrich. Chuning Lee. Bryce Tai. Rajat Sundar Ramasamy. Christopher James Yakus. Gavin Thomas. Yarden Kelman. Nicola Otala. Alexander Fraser Herring. Marcus Quintanilla. Andrew Cabos. Lucia Rebecca Wittico. Naya Francis Baltazar. Blair Schultz. Robert Karboviak. Reed Godby. Colton Lee Brown. Flynn Hill. Ben Klementovich. Hayden Richard Gebhardt. Jack Erstad. Zachary Faith. Jonathan Abrams. Brendan Paul Bradley. Stephen Liu. Ananya Shrest. Margaret Wusso. Ian Faber. Anna Sophia Rohr Warren. Matthew Janaziski. Jacob Oscar Landsberg Dean. Andrew Lee. William Owen McClung. Nathan Evans. Owen Craig. Nicholas Bogus. Carson Kolbrenner. Thomas Dunnington. Nolan Stevenson. Aiden Lusko. Dev Patel. Chase Ruprecht. Ginger Olson. Justin Travis. Jacob Spagnoli. Jack Stows. Alexis Elise Ellington. Elizabeth McPherson. Mark Krola. Jacob X. Brendan Sheets. Gabriel Augustine. Ethan Bro. Jacob Michael Vermeer. Christopher Ichiro Ladau. Gavin Morales. Caden Curl. Brad Lindroth. Eduardo Villalobos. Claire Kathleen Nalan. Nathaniel Meyer. Chase Johnson. Matt Bechtel. Christopher Kong. Alex McCauley. Muhammad Ibrahim. Atkin Lynn Arnstein. Sydney Alcaraz. Rachel Michelle Gardner. Ben Chappell. Cameron Pelkey. Krivi Gupta. Aiden Livingston Bagley. Catherine Kosmiski. Abigail Rindfuss. Abigail Mason. Eric Sorensen. Liam Harris. Bo Schneider. That's right. Will Hopkins.
Audio check. There we go. Okay. And now it is time to end the Spring 2024 recognition and graduation ceremony. On behalf of the faculty and staff of the Smead Department of Aerospace Engineering Sciences, we congratulate you on graduating today and wish you all the best with your exciting futures. Enjoy now, celebrate this day with family and friends. I now present the class of 2024. There's one final thing. Let's take this next step together, and you can get to turn your tassels from the right side to the left side to symbolize our transition into the next adventure. Congratulations, everyone. This concludes the ceremony. Thanks everybody, fans and family, for joining. Have a great evening and celebrate. Good night.